Welcome everyone to Documentation in the Era of Concepts and Ranges. My name is Cy Brand. I'm Microsoft C++ Developer Advocate.
And I am Christopher DeBella, software engineer at Google on the Chrome OS toolchain team.
So before we get started, one thing I like to do when I'm giving a presentation is there's usually some motivation behind it, some reason that I wanted to write the talk. And usually I tweet about it because I tweet about pretty much every thought that comes into my head. So I go back to Twitter and I look to see, hey, what was the tweet which came up with the motivation? So I went looking and I found this. I like to start off conference talks with a tweet I sent when coming up with the idea, but I don't have a good one, so I'm sending this tweet so I have something to put at the start of my ACCU talk. So here we are at the ACCU talk. But really the motivation behind this was, how do concepts affect our C++ documentation, and how should they affect our C++ documentation? So here's our agenda for today. We're going to start off with state of the art. What are C++ projects today doing in documentation? Then we'll talk about what makes good documentation on a few different axes. We'll talk about how do concepts in particular interact with documentation, and then we'll specifically look at ranges as a kind of case study. Then finally, we'll move on to, given all of this, how should we change the way that we document C++ code?
A quick disclaimer before we get started. Everything we say in this talk is our own opinion, and we will be making critiques of the libraries that we're talking about, especially in our case studies, as well as a couple of other resources. This is all made in good spirit. We think that the resources and the libraries that we're going to be talking about are all wonderful, and our intention is to point out the points in which we think can be strengthened, so that way users can get the most out of the libraries and tools that we are using. Right, so before we start, we should probably identify what kinds of documentation there are. And we understand there to be four broad categories of documentation. The first of which is called design, and that really details things like design documents, talking about how we're going to actually address the big problems and why we want to address them in this way. Then we have implementation documentation, which is a lot more focused on the specific implementation and describes all the details about that implementation, not the broad problems that we want to solve and how we want to go about solving them, but actually boiling down to the specific instance of the solution. Then we have internal APIs, which are things like the way in which we communicate with developers working inside the library or the tool. And we have external APIs. What's user facing? How do non-workers of the library or tool get to interact with our library? And taking those broad strokes, we can burrow down just a little bit further and work on the internal and external APIs in this talk. We won't really be focusing too much on design or implementation stuff. But a lot of this stuff can still be applied to the design and implementation stuff. It's just that our focus will be on internal and external APIs. And once we understand these four broad dimensions of documentation, we understand that there are four different ways in which we can communicate our information. The first being what we call learning-oriented tutorials, which are a very simple document that gets a user who knows literally nothing about the library or the tool, and gets them from zero to being functional. That is a critical stage of learning that essentially will shape the experience of the developer. And essentially, it's not going to go through anything like why is something this way, or here's a bunch of reference information. It's literally just going to say, okay, we're going to get you to open a code editor, write some code, compile it and run it, and hello world appears on the screen. Then we have goal-oriented how-to guides, which is a little bit more focused on someone who knows what they want, but doesn't know how to get there. And so what this does is it has you at a starting point and then takes you through the steps you need to get to in order to be competent in a particular aspect of this library or tool. Then we have understanding-oriented discussions, which burrow down a bit more into the design of things and get you to understand why certain design decisions were made, followed by information-oriented reference material, which is focusing on things like APIs and ensuring that you have all the information you need at your disposal to fully utilize this library or tool. And it's this information-oriented reference material that we're going to be focusing on today, but we are going to be touching on the other three aspects of this. And the Write the Docs conference is the best place to get the most information out of this, in our opinion. We have really only just been standing on the Write the Docs shoulders.
So let's talk about the state of the art. What are C++ libraries doing today? So we're going to look at a bunch of libraries which you may be familiar with. Here, for example, is something from the ABCL documentation. This is their stir split or string split function. So notice straight away that this is not a kind of traditional, here's a function declaration, and we're going to document all of the parameters and the return type and things like that. Now, this is very prose-driven, very example-driven documentation. It's thinking about what does the user need to know in order to achieve what they're trying to do. So this is generated from a Markdown document. There's this Markdown, which is then rendered to HTML and put on the web. An interesting thing about the ABCL documentation is that they also have documentation in the header itself. This is not exactly the same as what's on the website, but it is similar, and it's catering to a slightly different audience of someone who's like looking directly at the header of the code. That might be someone who's working on the library or someone who's writing code and wants to have a look at the implementation of this thing. Another example, which I really like, is format-lib. So format-lib starts off with this broad overview and usage-oriented documentation, giving you examples, giving you pros, telling you how to use this. Why would you want to use this? Then it goes into the slightly more traditional declaration-focused style of API. But this is still quite different from some more traditional like Doxygen style formats. There's still a lot of prose. There's still a lot of description and examples here. These APIs are split up nicely. They're kind of condensed. I find reading this very, very pleasant. This is generated from, well, it does use Doxygen, but it's the documentation is ripped out of the header using Doxygen and then rendered using Sphinx into a more prose-driven format. So here's the header with that Doxygen comment, and then here's the Sphinx, which pulls that information out using these Doxygen function declarations. So I really like this. It lets you intersperse your documentation very nicely whilst also making the most of the kind of automated style things that you can do with Doxygen. There's LLVM. LLVM uses very much like vanilla Doxygen. I've torn out quite an unfair representation of the LLVM documentation. There are some good parts of the LLVM documentation. This is just not one of them. But it's just to show you something that Doxygen can look like. You could just have all of these function declarations which hyperlink down to these large boxes with information in them. And this doesn't have anything which was not automatically generated. This is pure, just Doxygen has gone in, looked at the header, and then extracted all of this information and is giving it to the user. So there's no manual work involved here. This is kind of the three extremes. We had the pure handwritten stuff of ABCL, we had the semi-automatic stuff in format-lib, and now we have pure automatic here. Chris, can you tell us about Catch 2?
Yeah. So let's take a look at Catch 2 and see how it gets things going. So here is some stuff that we pulled from GitHub. It is some nice Markdown documentation, and it's really a learning-oriented tutorial that we've got here. So it's written in Markdown like Abseil, but it's focusing on getting the user to actually find their feet when using this library. And it's also got the goal-oriented how-to guides, such as when you want to migrate from version 2 to version 3. Catch 2 is in the middle of moving moving major versions, and so they have a migration guide that focuses solely on how to get from point A to point B. And we'll come back to Catch 2 in a little bit, but this wouldn't be a very good talk on documentation in the era of concepts and ranges if we didn't at least talk about a few ranges libraries. So we're going to talk about 2 ranges libraries in particular. We're going to talk about the grandparent to standard ranges, which is Boost Range 2.0. And here we can see that we have some design and understanding oriented discussions where the author has shown a particular example and talked about the reasoning about the convenience of ranges, and talking about why the pipe operator is interesting to them, and why they find that to be the most natural thing for composition, or at least the most natural thing in the C++ world. And then we have its descendant, the library range v3, which is the immediate predecessor to standard ranges. And it's written in Doxygen, more similar to LLVM. And it starts out with some with an intro that's fairly prose driven and gives us an overview of what ranges are. And then it moves into relying on Doxygen to document the majority of its APIs. So this is what one of them looks like. We'll talk about this style of API a little bit later, API presentation a little bit later on. But as we can see in the code, it's very, very much linked to the tags that Doxygen provides, so that way everything is generated by the Doxygen tool. And then following on from this, we have a little bit of interesting documentation. So if you get an error in range v3, you may notice that you get a lot of compiler diagnostics, and not all of them are relevant to you. It's a lot of it happens to be implementation details. There is one very particular important thing that the library author wants everyone to know, but doesn't have a way to tell the compiler that they want users to be presented with this information. And so they come up with this brilliant way to explain, hey, I need you to come and take a look at this specific comment. And so what they did was they worked out that on Clang and GCC, when an overload is when overload resolution fails, it will present the whole signature, but with the comments embedded as well. And so they have embedded, read this if your compile breaks here, to direct you to a giant block of prose text, so that way you can better understand how to use the range pipeline operator. And I think that's just absolutely brilliant. We'll talk more on that toward the end though. And then we have range v3's tests. And whenever someone wants to get started with range v3, I often encourage them to go and look at the tests, because this is probably the best form of documentation the library has. It has some real bulletproof tests, and you can see after reading the tests what the expected input is and what the expected output is. And so this is actually a form of range v3's documentation, because even though it's very much unit tests written, it does serve people who are reading the code and wanting to get started with the library, because the Doxygen is somewhat limited. So that's the state of the art. And we're now going to start thinking about what good documentation is. So, would you mind telling us what good documentation is, please?
Sure. So we had a look at a bunch of different resources, some from Write the Docs, and came up with this list of what is good documentation. So good documentation should be fit for context, clear, digestible, complete, accessible, and up to date. We're going to go through all of these in turn so you know exactly what we mean. When we say fit for context, we talked earlier a bit about what different kinds of documentation there are, like design, implementation, learning-oriented tutorials. These might be for different groups of people, right? Like if I'm a beginner using a library, I don't need the internal APIs, but if I'm working on the library, then for sure I do. If I'm a beginner, I probably would like some learning-oriented tutorials, but if I'm using this library day to day and it has a lot of nuances, I probably want the reference material. These are for different people. So whenever you're writing any piece of documentation, you need to be thinking about who it's for and cater to them in the best way that you can. So this brings us to our first key point of the talk, which is know your audience, know who you're writing your documentation for, and make sure that it makes sense for them. Moving on to clear. What's clear documentation, Chris?
So clear documentation is documentation that, that essentially allows for a user to read the documentation and walk away with a very strong idea of what it is that you were trying to communicate. You don't want them wondering, I'm not exactly sure what the takeaway was. I don't know what it is that I'm supposed to be doing, or touch wood, this doesn't happen. I have more questions than when I started. So let's take a look at a catch 2, because it's got some really clear documentation in our opinion. So this particular document is, I think, on the README of catch 2, which means it's the very first thing that you're going to see. And it asks a broad question. Why do we need yet another C++ test framework? And it goes on to list a myriad of other C++ test frameworks that someone could choose instead of catch 2. And so then after it asks that, it lists a bunch of bullet points about what catch 2 offers to the user. And so someone who's quickly reading this can read through the bullet points and go, okay, so my understanding of this particular document is that catch 2 offers all of these features coalesced together in a single package. And in their opinion, the other test frameworks that they mentioned might collectively provide all these features, but there's no single unit test framework other than catch 2 that provides everything together. And then we have another point, one of catch 2's strengths, which is that it has learning-oriented tutorials. This learning-oriented tutorial that we see on screen talks about how you write a hello world equivalent in catch 2. It does that by getting you to write a factorial function and then write some unit tests. It doesn't tell you why we're using this thing called require or what it's going to do. It just gets you to write it and then compile it, and then it will show a program that succeeds. And then it will get you to do something that's going to get it to fail, and then it'll show you the fail. But it may tell you that the require is what's driving that. It won't burrow down into what it is that require is specifically doing under the hood. It won't distinguish between require and check, which are 2 very fundamental parts of catch 2. No, it defers that to the goal-oriented how-to guide, which is, okay, so you've learnt how to write a simple unit test in catch 2. Let's now distinguish between require and check. And we'll also throw in require false and check false. That way you can have natural expressions, but still get the negated case. This is all something that's in a separate document, and it talks about one particular topic. So that way you have all your questions about a specific thing answered at once. And so this really comes back to knowing your audience. Are you talking with complete beginners? Are you talking with people who want a specific bit of information? Those 2 groups of people don't always overlap. And so in the case of beginners and specific information, They rarely overlap because beginners don't know what information they want, and people who want specific information do know what it is that they want.
So let's talk about digestibility. Again, coming back to the LLVM documentation, there's maybe a few aspects to this. One is that it doesn't really give you a whole lot of information. There's not really anything to digest here. You know, we can maybe use this information about where this thing is defined and jump around some references, but there's not really a whole lot here. It's mostly boilerplate, it's mostly noise. However, it is very clearly split out. It's clear what text belongs to what API declaration. It's easy to, if you're scrolling through this, find what you're looking for. And then also there are these hyperlinks that you can use to jump around. So there's a few aspects. Some of it is good and useful, some of it less so. Then looking back at the format lib documentation, you know, this splits things up nicely. It does have the clear delineation of what text belongs to what declaration purely by the indentation, but everything is a lot more condensed. It's a lot easier to just scroll through here and find what you're looking for, whereas LLVM, you know, had those huge doxygen blocks, which makes it a lot more cumbersome. You really have to use those hyperlinks at the top to navigate. It's also a lot more pleasant to read this, I think, because it's got the text, the prose, the examples, everything's nicely laid out. I feel like I can scroll through this and get what I'm wanting, and it will be a pleasant experience. And part of this comes down to using your tools. Like, we're not going to tell you in this talk what tools to use exactly, because we think different use cases will look for different tools, different communities, different people, different users might want different tools. So we're not going to tell you what to use. I personally like the Sphinx style, which format lib uses. But what we will tell you is to use the available tools to maximize your documentation quality. If you have tools you're already using, make sure you're making the most of them. Make sure that you're using them such that your documentation could be clear and digestible. And then if you think your tools are not supporting you enough, maybe look for different ones. Then coming to complete, not to rag on this LLVM documentation, like I said, there is some good LLVM documentation out there, but this is obviously not complete, right? Like we can maybe intuit stuff about these declarations, like LLVM get bitcode module tells you kind of what it does. You can maybe work out this is a memory buffer, that we've got some output parameters because they're prefixed with out. You can intuit some of this stuff, but it doesn't surface it to you. It's not immediately clear. It's not complete. It doesn't have everything you need, especially because, you know, there's this get bitcode module and get bitcode module 2. Well, what's the difference between these? We don't really know. It's not complete documentation. Chris, how about accessibility?
Once you've got complete documentation, you need to make sure that it's available to everyone and available to everyone that isn't like you as well. So we're going to start off by talking about accessibility in terms of, can I just simply find the documentation? Is it literally accessible to anyone? So let's take the example of splitting a string because that is a very important operation in computer science. And let's find out, we know there's absolute str split. There's also a boost string split, and because we have those two, and there's not a from a user perspective, there may not be a standard one. We'll just go to the web and search for splitting a string, and we get met with a bunch of search results. Nothing's taking us to absolute str split. Nothing's taking us to boost. And nothing's taking us to the C++20 standardized way of splitting a range. So we don't have a very good start here, because one of the most common operations that a software developer does is goes to the web and searches for things, and we don't have that in any of our search results on the first page. So I'm going to kind of shortcut this because I don't remember where absolute str split actually popped up, and just say that there is a standard splitting operation in C++20, and we'll go to the CPP reference page for that. Had to click through a few links to get there, including the C4B reference documentation, but we got there. And so we're met with this. And you look at this and there is no example here. We went with a whole bunch of reference details, information that that don't tell us how to use this operation or what it is that this is going to help us with. So let's scroll down to go to the example. Scroll down a bit more. And we're starting to see the example just a little bit more. And so that's four different scrolling through pages that we have to get through in order to see the example. That's not particularly accessible because the audience that's going to benefit from this example is pretty much everyone, whereas the reference information is not necessarily going to be beneficial to everyone. And so making sure that the information that is most useful is the most easily accessible information is critical to ensuring good experience with your documentation and ultimately your library. And then once we thought about this, we should really think about accessibility in terms of people. Documentation exists for people. It does not exist for technology. It exists for humans. And with that in mind, we need to be thinking about how to write documentation so that way it caters to the broadest possible audience, such as having alt text in images if you need to have images. If you can get away with not having images, that's even better. And using Unicode appropriately so that way screen readers can ensure that things are being read out as words rather than being spelled out as individual Unicode characters. And there's a lot more, and we're not going to be able to go into this in any great detail. So we do recommend that you look at the accessibility guidelines for writing and beyond from the Write the Docs conference when you're writing your documentation. So that way you understand what it is that you need to do in order to make sure that your documentation can be read and understood by as many people as possible. So that's the accessibility stuff. Then we have up to date, and being up to date is for documentation is critically important. If documentation goes out of date, then it becomes worse than useless, because useless would mean you don't get any information. Being out of date means that you are getting old information that is incorrect, and that could lead you to make poor design decisions, rely on something in an inefficient way, and we want to mitigate these sorts of things. So we want to keep our documentation as up to date as we possibly can. And so we're going to go back to Absol Straw Split because that's got this disjoint idea of documentation where we have web-based documentation and we have code-based documentation. And as I noted at the very, very start, these aren't the same documents. It's not like we have a single true copy of the documentation that's in code and then it's mapped over to Markdown by some tool. No, these are maintained independently. And so that means that we have to maintain them separately. And as a result, that means that if we update the documentation in the code because an external contributor has gone and updated the code and they aren't aware of the Markdown documentation, and then the reviewer, maybe they're having a bad day and just have missed that the Markdown was unfortunately skipped, then that means that the documentation in the code is accurate, but the Markdown documentation is no longer in sync with what reality says. And that's going to be a huge problem because people are going to depend on both of these things. So what we need you to do here is we need you to be vigilant. We need you to make sure that you understand where all the documentation is coming from and ensure that it is all consistently kept up to date with everything else. The worst thing that you want to have is have one piece of documentation be up to date, the other one be out of date, and then not know which one to trust. And so you might be thinking, well, should I have a split thing? Maybe I should just go with the Maybe you should just go with the encode stuff because it's the most convenient and devs are probably going to love that. Well, we did an informal survey on Twitter shortly beforehand, and it turns out that the overwhelming majority of people want external documentation, like the markdown stuff. But then a slight majority over the I want external documentation said, I also want internal documentation. And so that means that what Abseil is doing is actually catering to the right audience. They have the external stuff that almost everyone wants, and then we have the internal stuff that at least half the people in our survey wanted to see as well. And so it really comes back to knowing your audience and knowing what to give them. In this case, giving them both things is very important. And so the key point for this particular section is that we want you to be measuring your documentation quality on several axes. We've talked about quite a few different ways in what makes documentation good, and that is relevant to understanding how to build your documentation so that way it is available and understandable by everyone. There's no point in saying, okay, well, my documentation is fit for context, I can move on, if your documentation isn't also clear and digestible. Similarly, if it's once you've got those things out of the way, if it's not accessible, then it's not really going to help anyone at all. And then if it's out of date, then everything just sort of crumbles.
Cool. So that's what is good documentation. Now, how do concepts themselves interact with documentation? To understand this, first, of course, we need to understand what is a concept. So, Chris, can you tell us this?
Okay, so very, very quickly, but formally still, a concept expresses the syntax requirements, semantic requirements, and complexity requirements for an algorithm. Essentially, that means that an algorithm has a bunch of things that it needs in order to work, and if we don't meet these things, then it's going to be problematic. We say that a type models a particular concept if it meets all of these requirements. So we'll quickly go through a very quick example. For example, we have a concept called stood size range, and on a type R, and that documents that type R is a range, which means that if we have some object called lowercase r, we can call ranges begin on this object and ranges end on the object, and those two things just work. And so when we call another function called ranges size on R, this guarantees that it returns the number of elements that R has in amortized constant time, and it doesn't modify R, and it always works if R is a forward range. Now, quickly before we move on, I said that there are syntax requirements, semantic requirements, complexity requirements. The fact that it returns the number of elements implies that it's returning some integer or integer-like thing, and that basically is the syntax requirement. It's returning an integer. And then the amortized constant time is the complexity requirement. And an example of a semantic requirement, not all of them, is that it doesn't modify R.
Cool. So I do see we've got a question. I think we're going to come to this in a little bit. How would we see documentation work in a perfect world? That will be part of our recommendations later on. But for now, let's look at some examples of concepts. So say we have this function register callback, which takes some f whose type is a template parameter. Now, what does this function do? What can you pass it? Well, we can kind of intuit that, okay, we're registering a callback. This type is called f, so it's probably a function, right? But we don't know what the function should take as an argument or what it should return. We can't tell without either having some documentation on top of this or by looking at the implementation. So let's say, okay, we just try something. We pass it a function which takes an integer and we get a compiler error. All right, what went wrong? Let's have a look at this compiler error. Well, no matching function call. And then there's a bunch of stuff in the initialization of function template specialization, candidate function not found. And we have to kind of dig kind of deep to work out exactly what's going on here. Cannot convert argument of incomplete type void star to int for first argument. So if we kind of read between the lines here, we can work out that this function expected invocable from void star to something, and we gave it something from int to another type. So there's a mismatch here, but we kind of had to do some work and it wasn't clear from the signature. However, if we went back and we changed the function declaration to be this, then as long as we know what std invocable means, which it means that something which models invocable of some type or some list of types is a function or a function object or a closure or whatever, which can accept those as arguments to its call operator. Once we understand this, well, this is documentation both to us and something which the compiler can enforce. All right, we look at this, we immediately know, we don't necessarily know the semantics of what this callback is doing. We might know that from our domain knowledge or from other documentation, but at least we know more about what this function is doing. And the compiler helps us there as well. If we do the same thing that we did just a minute ago and passed an int closure, then it says, okay, no matching function. The candidate template was ignored because the constraints were not satisfied, because std invocable of our lambda and void star evaluated to false. This tells us exactly what we got wrong. So this is both documentation for us. It's something which the compiler can enforce, and then it's something the compiler can communicate back to the user. Let's look at a slightly more complicated example. This is a Cartesian product adapter. We're going to give it a bunch of ranges, and it will give us back something representing the Cartesian product of those ranges. Now, the constraints here are a little bit more complex, but if we, again, know that shared knowledge of what a viewable range is and what a forward range is, then we could say, okay, well, we need to pass a bunch of things which are all viewable, they're all forward ranges at least, and we need to pass at least one of them. This is communicating to the user what the constraints of this function are. And again, if we get it wrong, the compiler is going to tell us. Like if we have a function which returns an R value vector, then if we try to pass that to a Cartesian product, this shouldn't work because this vector is going to get destructed, the memory is just going to be reclaimed, and if we try to do anything with this Cartesian product, we'll be pointing to reclaimed memory. It's undefined behavior, it's a dangling reference or whatever. And the compiler can actually work this out because of the constraints. It will say no matching function, candidate template ignored because the vector does not satisfy viewable range. If it was an L value reference, it would. This would all be fine. But at the moment, it's saying, oh, this thing's going to dangle, don't do that. So this is communicated back to the user. And so we said earlier that we want to use the available tools to maximize your documentation quality. And what we're saying now is that, well, concepts can be used as a documentation tool. So that's how how concepts interact with documentation. Now let's look closer at ranges as a kind of case study. So we talked about what a concept is. Well, what's a range? Chris?
Okay, so a range is essentially something that we can iterate over. A range has what we call an iterator that denotes the starting point of the range, and we have a sentinel that outlines the rule in which we finish iterating over this range. Now, in between C++98 and C++17, that constituted a second iterator, occasionally in integer, but very rarely. And in C++20, we broadened this, generalized it to mean something that we can compare to an iterator, but it could be a lambda, or simply just say to the iterator, hey, look, you decide, I'm just going to roll with whatever it is that you want. But in C++20, the critical idea of a range object is that we can call ranges begin on the range, and it will return us back an iterator. And when we call ranges end on it, it will return us a sentinel that is related to the iterator that we got back from begin. That's the fundamental part of a range. And there are different kinds of ranges that provide different functionality. For example, we talked earlier about a sized range. That way, when we call range a size, we can immediately get the size back in amortized constant time, as opposed to having to walk through all the elements and count along the way. And we have things like forward ranges and bidirectional ranges and random access ranges that very much model the iterators that are underpinning them. So, for example, with a random access range, if we were to call ranges begin on the range, then the iterator we get back can be arbitrarily moved to arbitrary elements in the range itself, and that happens in constant time. So, how should we think about documenting ranges? CPP reference is one of the world's biggest places of documentation for C++. And in 2020, I was teaching a course that involved ranges. And I realized that the documentation for ranges was pretty sparse at that point. And so I quickly went to CPP reference to go and, because it's a wiki, and add the documentation for the algorithms. So that way, at least that would be present. And I took the existing documentation for the C++ 98 algorithms, and then just tried to throw in the changes that happen between C++ 17 and C++ 20, the ranges algorithms, to make it so that way everything would be, at least what I thought, clearly communicated, and we ended up with this. Now, Si, do you want to do a quick check on how well this goes against what we've talked about so far?
Well, I mean, we did say that concepts could be used as documentation, so maybe this is fine. But really, we said that concepts can be used as a documentation tool, but documentation tools can be misused, and so can concepts.
Yes. All right. So earlier, I was complaining about how with split with split view, we had the example at the bottom. What if we put the example at the top? How does this? And then we have the API underneath. You can just see the API down the bottom. But now what we've done is we've taken the bit that pretty much everyone will need to know, put that at the top, and then moved the information stuff. Sorry, the dense information stuff underneath the example, so that way people who genuinely want this information need to go and do the work, rather than people who just want to know how to use this. What do you think it is, Si?
I think this is definitely an improvement. Like, it's a lot clearer how to actually use this thing, but it's still not immediately telling us what this thing is and why we might want to use it.
Okay, so how about we put the description at the very top as well? And something that I noticed about my own behavior and things that I've seen people in chat rooms talk about as well is they often go to CPP reference to find out what header something's in. So I took that from the API section, bumped that up to the very top, because it seems like that's a pretty useful thing. It's also fairly non-intrusive. What do we think of this?
I think that this is a vast improvement on what there was before. I mean, just by moving things around a bit and adding a description, thinking about what the users want, I think this has made the documentation a lot more immediately useful. It's more digestible because we're not immediately hit with this mass of concepts and documentation. It's clearer, I think, because it now has that nice documentation. It's just better documentation. It's thinking about the user a lot more.
Right. And so this comes back to knowing your audience. CPP reference, whether or not it was intentionally made for this, has become an authoritative point for people who don't want to be consulting the standard. And that also includes getting people up to speed on things, people who want to learn how to use a particular feature. And so putting that information first caters to pretty much everyone, because even experts forget how to use things, and seeing an example of something in action is a quick way to jog the memory, and it just caters to a much broader audience than being met with this giant wall of text that even intimidates implementers.
Well, so let's think about not just moving things around and adding a bit of description. Let's think about what people need to know about our ranges. So, for example, can my range be const? If I have some range adapter of some other range, can I const qualify that and then iterate over it? Well, let's say that I have a join view of some other range and I want to know if it's const iterable. How do I work this out? Well, first I need to have the domain knowledge that I need to check the begin and end functions. So I scroll down to the member functions and I open the begin and the end pages in new tabs and I go and look at them and I look at the constraints and I see, okay, we've got const qualified versions here and they require that the const underlying view has to be an input range and its reference type has to be an actual reference, i.e. it can't be a proxy type. And so this required a bit of digging. This required me to have that domain knowledge to know what I need to check. It would be a lot nicer if this was just immediately surfaced because it's something which I might want to know as a user. Or let's think about an even more slightly different example, Chris.
So in C++98, we had ranges that only took a pair of iterators. That's pretty much what solely defined a range, if we ignore the rare integer cases. Whereas in C++20, we get iterators and sentinels. And that's a completely different type, that sentinel. So we may want to know whether or not we have what's called a common range, which is when we have an iterator for the begin and an iterator for the end. And whether or not our range can be passed to a std find, for example, because that's what is being used in our API at the moment. Can we do that? So let's think about lazy split, which is a cousin of split. And so upon inspection, it's very difficult for us to see whether or not we have a common range because both the return types are auto and they're not using trailing return types. They're just straight up auto. So we need to go down to the prose documentation. And we can see from for the first case, the non-const case, that if we have a forward range, it's also a common range, then we're going to get back we're going to get back an iterator of the same type. But for the second case, the const qualified one, it's actually a lot more complicated because we need to go and look at some code in order to work out what's going on. We see that if we have a forward range and the const qualified version of our range is also a forward range, and that const qualified version of the range is also a common range, then we get back an iterator and thus have a common range. But otherwise, we get back this default sentinel, which means that it's not going to be a common range because we have two different types. Now, that's a lot to get through, and we haven't talked about how this outer iterator and simple view thing both comments and don't have any particular description related to them. So this isn't particularly giving us information in a clear way. We have to do a lot of thinking in order to work out yes or no, this might be a common range for my specific situation. So we should probably think about what users of ranges actually need to know. And we've come up with a list of things that we think are critical bits of information that a user of ranges needs to know. Starting with the type requirements. What is it that we need to be doing in order to satisfy the concept's syntax requirements? Then we need to know what the pre and post conditions are of the range. This factors into the semantic requirements and briefly touches on the complexity requirements. We need to know how to construct a range object because otherwise we're not going to be able to actually start using it. We need to know what its reference type is. What is it that when we have an iterator, what are we going to be getting back when we dereference the iterator? We need to be thinking about what kind of range category it is. Is it an input range? Do we have a forward range or something stronger? Will we be able to call std range's size on this function, on this range object? And can we actually pass it to C++98 algorithms? That's the immediately preceding question that we had. What about const iterability? because not all ranges are necessarily iterable when they are both mutable and const. There are some cases with caching that prohibit const iterability, such as with filter view. Finally, do we have a range that is a borrowed range? So these are all the fundamental things that we need to know. And so how do other ranges libraries present this information to us? Well, we can look at range v3 stride. And as with the previous examples of range v3, this is all doxygen. And as we saw in the chunk view example at the very start, the doxygen was pretty sparse. Here, it's very much the same. So it's not particularly fit for context because it's not really addressing anything in particular. It's also not clear because when I look at this this particular example, I have all the same questions that I had when I first went, how do I use stride? I don't have any new questions, which is great, but I don't have any answer questions. It's not digestible because the information is sort of just there. It doesn't really particularly give us anything in an understandable way. It isn't complete because I still have all my questions and there's not that much information. It's not accessible because I had to click through a few things to get here. There wasn't a nice index of views that I could just look at and go, okay, stride's the one that I think I want. Let's quickly go and learn how to use it. But it is up to date because there's just so little information. So it does get one of the things. Then we have the information that ranges users might want to know. And when assessing it in this on this, it does meet the type requirements bit of information because it does have it says a precondition at the bottom and then it uses the word requires and tells us that the difference type needs to be integer-like. But it doesn't meet the pre and post conditions thing because we don't have any other information, and it doesn't tell us how to construct anything. It doesn't tell us what happens when we do if it's an iterator or if it's going to be something stronger than an input range. Or even if it is an input range, it may just be an output range. We don't know if it's a sized range or common. We don't know what happens if it's const iterable. And finally, we don't know if it's a borrowed range. So there's a lot here that does need to change in order for it to meet our criteria to be good documentation and useful ranges documentation. But let's contrast this against Boost Range 2.0's Strided, which is its equivalent. It is fit for context because it does have a clear audience and does fall into one of the broad categories that we were talking about. It is very clear because it uses bullet points, sections things off, has indentation, uses different fonts, has links. It's digestible for the same reason. In terms of clarity, we can walk away with feeling like we have some sort of answer to a question. It's more accessible than Range v3's one, but I still had to do a little bit of searching for it. So it's getting partial credit here, but I think that may be with context. And it's up to date, at least at the moment. We'll talk about that again in a moment. In terms of the useful ranges information, it's got a bit of stuff that needs to improve. For example, it doesn't talk about the type requirements at all. I don't know what kind of a range I can pass in, or whether or not I can pass in a floating point number, or if it has to be an integer. But it does tell us the pre and post conditions, specifically a precondition that n needs to be a positive number. It tells us how to construct it using the example, and also in the function at the top in the table. It doesn't tell us what the reference type is, which is a bit unfortunate, but it does say that it's a single pass range. And a single pass range is another way of saying an input range, which means that we can iterate over it, but when we move past an element, we are never allowed to go back and look at previous elements. It doesn't tell us whether or not it's a sized range, which is unfortunate. And then we're going to give it a bit of a pass at the moment on whether or not it's a common range, whether or not it's considerable, and whether or not it's a borrowed range, because these things came about a decade after range 2.0 joined the Boost family. But since we're now moving into the 2020s and these particular ideas have been around for a while now, that information is probably going to start needing to be useful for range 2.0 to be to keep up to date with the notion of what a range is in the modern era. So how should this information be presented?
So we said earlier that concepts can be used as a documentation tool. So why don't we use concept as our documentation tool? Here's cycle function in range v3. Let's try and take this and make it better. So let's start off with the name, a short description, and an example, just like we had in the CPP reference. Moving all of this to the top just gives us a much better idea of what we're dealing with. Then we're going to think about all of the other things. So we're going to say our class is cycle view, and then we're going to go through all of the bits of information the user needs. We're going to tell the user what the type requirements are. We require that V be a forward range in a view. We're going to say that the reference type is the same as the underlying one. We're going to say that the category here is a little bit more complicated. So we're going to think about how we present this to the user. We're going to say, split this out into bullet points and say, okay, well, it's random access if V is both random access and sized. Otherwise, it's bidirectional, as long as V is bidirectional and common. Otherwise, it's a forward range. So as long as you know what these concepts mean, you can just go down this list and say, okay, right, I see what's going on here. Whereas if you have to look at the code, this is quite complicated to extract. Even though I knew exactly what I was looking for, it took me a while to understand exactly what the category of this type would be. It's never size, it's never common, it's considerable as long as V is, and it's never borrowed. We just take all of this information, which a user could extract if they had the domain knowledge and the time, and just immediately surface it so it's right there. And then we say, okay, well, if you want to pipe it into something, here's how you do that. If you want to construct it, here's how you do that, and here's what it constructs. We're just giving you all the information you actually need. And look, this is even smaller than the range v3 documentation was, but it's giving you more information. So we said that you should measure your documentation quality on several axes. So why don't we do this? Is it fit for context? I think so. I thought clearly about who is going to be using this and what they're going to need. It's going to be people who are trying to consume this library. And we thought about all the things which someone consuming a range library would need to know, and we've given them that information. It's fit for context. Is it clear? I think so. I think we're thinking about how to express this information. We're using bullet points if we need to. We can split things out. We can, because it's all prose and we control all of it, we can think about how to present this information in the clearest manner to the user. Is it digestible? I think the fact that we can make this all smaller, we can do the layouting ourselves. We can take things and put them in a different section if we thought that that was useful. That helps everything become more digestible. Is it complete? Like I said, we thought about all of those constraints beforehand and what the user needs, so I think so. Is it accessible? That kind of depends on how you put this on a web page, where you put it, how you give people access to this. So that's maybe, it depends. Up to date is the hardest one of these. Up to date, this is handwritten documentation, and it requires knowledge of some fairly in-depth elements of ranges in order to actually write. So someone could very easily come along and make a small change to the implementation of the library, which affects one of these without necessarily knowing it. So you would need to take a lot of care in maintaining this documentation and keeping it up to date. But I do think it's worth it. Let's look at a more complicated example, chunk by key view. So this is a view which chunks a range into subranges where the consecutive elements share the same key given by some projection function. It's a bit of a mouthful, so we have an example. We have a cat, cats have names and ages. We have a bunch of cats, and then we group them. We say, okay, chunk by key on age. And this is going to give us one group of the cats who are 12, and then a group of the single cat who is 9, and then another group of the cats who are 12. So this is showing an example of how to use it. And then we think about all of our other things. And some of these are more complicated, like our requirements are that V is a forward range, a view, and we have this indirect unary predicate thing. And this is kind of complicated. So we could think about maybe we want to hyperlink this to some other documentation. Maybe we want to express this in prose, either before or after this. There's no end to what we can do as long as we're thinking about our audience. Then we think about the reference type. Okay, this is a pair of, again, we have this indirect result T and subrange. So maybe in this case, we'll do an example and say, okay, well, if your range is a vector and your function is a function pointer from int to bool, then you're going to get back a pair of bool and a subrange of vector iterators. So we can have examples, we can have prose, whatever we like. And then we have all of these things, which are fairly straightforward in this case. We have all our categories, size, common, so on and so forth, and how to construct it. And then we also have some additional constructors, like we can use this piping syntax. So we show how you could use that. And then we could think about, okay, well, we want to lay this out on a web page, and it could look something like this. This is documentation that I have for a range library, which I wrote. We're just presenting the information in a nice way. And we have all of the API documentation laid out like this: clear, digestible, complete. So again, coming back to these, I think this is the same as we did last time. It's fit for context, it's clear, digestible, complete. I showed how you might lay it out on a web page, as long as you make that web page navigable and think about all the accessibility constraints, then you can make it accessible, up to date, the same issue. We would need to be very careful about that. So that's our case study on ranges. Given all that we've talked about, how should we change the way that we document C++ code? Chris?
So as users, what should we be asking of our implementers? When I say implementer here, I am not just referring to people who read the C++ compiler and standard library, although we will be touching on that in a moment, but rather what can we be asking from our library authors, from our tool authors, and our resource authors, so that way we get the best possible documentation and communication, because all this stuff, whether it be an API or documentation or user experience, all of it, all software exists for people, and all of this stuff is meant to better people's experience and lives when it comes to interacting with software development. So the first thing that we should be asking our implementers to do is to ensure that the criteria that we outline for good documentation is met, because that is how we start thinking about getting good documentation. The next thing that we can think about is that if we don't ask for things, it's not going to get better. One of our friends quoted something anonymously from a meeting that they were in, where one of the compiler developers in the meeting said that the only reason that we don't make our C++ compiler error messages better is because users don't complain about them. That's pretty harrowing, but it's showing that people are okay with the status quo, and so implementers don't have an incentive to go and make the situation better, even if the situation isn't exactly crash hot. And we're not kidding when we think about diagnostics being something better. This is an example of a Rust error where it goes through and points out issues with the code, and then takes you to specific issues within the Rust language, which would be the equivalent of either a proposal or a defect report in C++ standard land. And then if you want more information about this particular error to understand why something needs to be the way it is, it actually says that you can provide this explain flag and then a specific code, and then it will replace this diagnostic with some really nice prose, with an example that will help you work out what it is you need to do in order to get your code working. And then if we relate this back to C++ and ranges libraries, we can go and think about the range v3, read this if your compile breaks here example. And it'd be nicer if instead of having to rely on the user reading through the sea of diagnostics that you get back and hopefully finding this message and understanding it means go and look at this specific header. It'd be nicer if we could just put this into, say, an attribute that explains why the compile broke, or put it into the delete, so that way the compiler just goes, okay, I have some text that I need to present to the user. Let's do that, and then the user gets this, and it's clear and fit for context rather than hoping on a chance. So then.
That's what we as users might ask from our implementers, but as implementers, how do we help our users? And that's not just if we're implementing C++, that's if we're implementing anything. And this comes back to all the key points we've had in the talk: to know your audience, to measure your documentation quality on several axes, to use the available tools to maximize your quality. The concept can be used as a documentation tool, and we saw some good examples of how you could do that specifically for ranges. I think you could apply that elsewhere, but also documentation tools can be misused, and so can concepts. I think if you think about all of those key points, you think about what makes quality documentation, you think about your users. If you apply all of these things to your documentation, then you can make your documentation as wonderful and useful as it can be. We've got one question already. In a perfect world, how would you see documentation work? What concepts, tools, etc.? For example, sometimes I wish there was support within the language and IDE for code to automatically link to documentation, something like a hyperlink. Yeah, so I think there's a few different areas of this, right? There's the how should the documentation be thoughtfully laid out, and what content should the documentation have? What should it communicate to the user? And then there's the how do we use technology and tooling to leverage this and make it the best it can be? So I think we mostly covered that first point of what does the user need to know? What do you need to think about in order to get the best documentation? In terms of tooling, I think there is a lot of potential there, like Chris mentioned some of it right at the end, and how we could hook documentation into compiler errors and things like that. I think that's still very much an open topic. Other languages, like you mentioned in the second question, how do we feel about Rust documentation? Other languages are thinking about this and integrating documentation into like their testing tools and things like that, so you can generate documentation which automatically runs tests. There's a lot that we could be doing here in C++. I don't have a feel for what the perfect world would be, because I think that depends on the kind of documentation you're writing for, and what library or code you're documenting. But I do think that as long as you're following all of those principles and you're looking out there and doing research, then I think that will help a lot. What do you think, Chris?
Yeah, I think that it's very much context dependent, and that there's not a perfect world. There are multiple perfect worlds. Yeah, I think that's a very good summary. Thanks, Si.
And then there's a second question here. How do we feel about Rust documentation? In my experience, the Rust documentation has been good. So there's a difference between Rust and C++ in how the template systems work, right? So in C++, we can have a template and we can put constraints on the template. Starts wide, right? It can accept anything in theory, and then we can constrain this function by adding constraints onto it and say, okay, well, you need to pass something which is a forward range or something like that. But the C++ templates start wide and we narrow them, whereas Rust traits start with nothing and then you have to expand them, right? If you have a Rust trait, you can. If you have a Rust generic function, and you want to, you have some things which are, template parameters. I don't know what they call them, but if you want to add two things together, which are generic, then you need to say in your declaration, I need these things to be addable. You can't just add anything in the body of your function and then it magically work. You have to start from nothing and widen. And that has some knock-on effects on how traits can be used as documentation, right? Because C++, we can be imperfect because we need to think every time we write a function what constraints we want to put on it, whereas Rust, if they don't do that, it won't compile. And that means it is slightly different in terms of documentation because the Rust one is kind of provably what the compiler is expecting. That's a little bit of an aside, but I think that taking into account differences in languages and how these different systems work does affect how the coding constructs can be used as documentation. Do you have any thoughts there, Chris?
Yeah, I think you, again, hit the nail on the head. C++ doesn't have a notion of separate checking. So that means that the documentation is both for implementers when it comes to concepts and for the users. We want it to be for the users as much as possible, but if you aren't making sure that your documentation in the API is up to date, then users are eventually going to have that knock-on effect and feel the pain points. Does that answer the question to the asker?
Anonymous attendee is the questioner, so we'll see. We've still got a bit of time left, so if anyone has any more questions, feel free to drop them. Otherwise, I'll just sit here and ramble a little bit. Like I say, I think that compilers in particular can do a lot of work here, and I am working on some of this myself, trying to improve stuff within MSBC and get some papers out there to help everyone.
Playing over here, it's actually kind of interesting. We the way in which we accidentally were converging on the same topics.
Yeah.
So I see a question on contracts here. It says, contracts, any thoughts for a future talk that covers this with respect to documentation? So for contracts, yes, contracts are an important part of documentation. For those of you who aren't familiar with contracts, these are things like asserts that essentially give you a way to check your preconditions, actually check them, and give you important information about the reason why your function may have not met the precondition and what those preconditions are. In a context of C++ contracts, that is a desirable feature from the committee and the community about embedding that into the actual interface, saying on the interface, the precondition of the divide function is that the denominator is not 0. And that's a pretty important thing to be thinking about, because it forces stuff into the API, but then also gives us functionality at runtime if we want it. So yes, that is an incredibly powerful piece of documentation. But Sai and I haven't really talked about thinking about a future talk. But what I can recommend is that you look at what contract libraries are available and get those used in your software, so that way you can communicate with devs at runtime about things that are going wrong. And if you can't do that, then at least start thinking about having asserts and putting in a bit of a strings, that way you can say, hey, look, this is why the thing went wrong. That will ensure you communicating runtime requirements at runtime when things go wrong. Does that answer the question?
I think Chris needs to run, and we're about at time now. So thank you very much. If you would like to ask any more questions or just chat to us, you can find us on Discord, or we're at Twitter on at Tartan Llama and CJDB_NS. So I hope you enjoy the rest of the conference. Thanks very much.
Thank you. Bye.